The following teacher development program is brought to you by the MultiChoice Africa Foundation.
I hear you, but this is not even a big loan. She's been with you for 5 years. Now, I'm going to have to follow this up. I wouldn't be so sure if I was you, mister. I know my maths, and you'll be hearing from me soon. Could kill that guy.
Time out. Who are you trying to kill?
My cousin Lindy was boss. He's refusing to give them a loan to tide them over, and her husband's sick. But you know what? The company newsletter boasts about the fact that everybody there is fair and generous.
Maybe they are in other ways.
No. The average salary there is 6,000 Rand a month. And I know for a fact that all 13 workers get 2,000 bucks.
But how can they say that then? It's a lie.
Well, not necessarily. It depends on how the average was calculated. Ugh.
This will calm you down.
Thanks.
What do you mean when you say how the average was calculated?
Look, if the foreman earns 25,000 Rand a month and the boss 39,000 Rand a month, then the average could very well be 6,000 Rand. So they're not necessarily lying, but they're neglecting to mention how the salaries are distributed among the workers.
So the figures aren't reflecting the truth?
In a sense, no, but yeah, they are. Weird, huh?
Yeah. Well, I'm interested in all that, but duty calls. I'll see you later. Hey!
Hi.
I thought you could quickly show me some averages.
How come?
Sport, what do you think? Averages instead make sport far more interesting to watch.
Then you're going to have to listen carefully, because we're talking a bunch of data here. How best to find a figure that can represent that data. But I'm not going to be using sports figures. I'm just going to concentrate on the salaries of my poor cousin and her colleagues.
Okay.
Right. There are 3 different ways of working out averages. First one, have arithmetic mean, which is the average score. Then you have the median, which is a central most score. Then you have the mode, which is the most common score.
I'm sure you're going to explain all 3 in simple English.
Of course, man, come. As you can see, this one's easy. The 13 workers' salaries times the 2,000 Rand that they earn, plus the 25,000 Rand of the foreman, plus the 39,000 Rand of the manager. And you divide that by 15 because there are 15 people in the company in total. When you add all that up, it gives you 90,000 Rand, and you still divide by the 15, and it gives you 6,000 Rand.
Yeah, so the arithmetic mean is obviously what the newsletter used. It kind of hides the truth a bit. But what would make it better?
Well, I'd say the mode or the median, the whole collection of data, and you put it from small to big. And the number that's in the middle would be taken as the average, but it's not used in everyday life.
Now, show me.
We have 15 items of data here. The 13 2,000s from the worker's salary, and 25,000 of the foreman, and the 39,000 from the manager. And this one here is a middle number. There's 7 items on top and 7 at the bottom. Comprende?
See.
This 2,000 Rand is the average salary, which is a far better reflection of what that company is paying.
This is quite interesting. So there is one kind of average left, and there is the mode.
Well, that one's also quite simple because you just look at the most common number, and the most common number here is obviously
2,000.
which is again a better reflection of what that company is paying.
It teaches me how to look at stats of the media quite differently.
So glad kids are learning about this at school already.
In math literacy, I presume.
What else?
Jonathan Jacobs is teaching a lesson on mathematical literacy and the media at Macaulay House. He starts off by handing out different newspapers to the learners and asks them to look for articles or headlines related to maths literacy.
Oh guys, I found a percentage. Guys, I found a bar graph and a line graph.
Guys, don't you think this would count as maths in the media?
I don't know, it just looks like numbers to me.
No, I think you've got to do a sum there somewhere.
It's clear that every newspaper is full of mathematics. Figures and graphs give an air of expertise and objectivity to a story that makes us trust what is being said. The big question is, can mathematics ever be used to slant a story? Jonathan demonstrates how survey results can be deceiving.
By way of example, which of you girls like tennis? Okay, 1, 2, 3.
Jonathan has predetermined who likes tennis in the class. He sends out a journalist to specifically interview the tennis fans on their favorite sport.
Well, trust me on this and go interview the girls.
What sports do you like?
Tennis.
What sports do you like?
Tennis.
Right. And you? Tennis, of course.
How many, out of all the girls that you interviewed, how many said they like tennis?
3 out of 3.
Okay, girls, now I want you girls all to imagine a massive headline on the newspaper saying, all girls interviewed at Macaulay House, 100% of them like tennis. So imagining that headline, what do you think, how do you feel about, and what do you think that headline would suggest about girls at Macaulay House?
Wouldn't that mean that all the girls who go to Macaulay like tennis?
Only a minority of the class like tennis, but a skewed interview can make it look like everyone does. When a percentage sign is used, people assume that a large sample of people were interviewed, that they were fairly chosen, and that they were not influenced by the interviewer. Jonathan hopes that by now the girls will be skeptical enough of the use of percentages to analyze this advertisement mathematically.
Since 85% of South African pediatricians and doctors surveyed feed their own little ones purity.
It only says 85% of pediatrics and doctors surveyed, so the other people who are not surveyed might prove it wrong. So it doesn't necessarily mean that it's true.
Probably find out that they only interviewed 5% of the pediatricians and doctors and not all of them.
Because it's only been 85 out of 100 doctors and pediatricians that were surveyed. So it means it's not really accurate.
Many of the girls think that a percentage is a fraction out of 100. Accordingly, this should mean that at least 100 people were interviewed. A few have realized that more or less people could have been interviewed.
How many do you think that they interviewed for this survey?
Probably the first 100.
850. But guys, this advert could be deceiving. Just because it says 85% of South African pediatricians doesn't necessarily mean that they interviewed all 1,000. They could have only maybe interviewed 20.
Excellent.
Jonathan asked the learners to calculate 85% of each of the sample groups. It turns out that the company could have interviewed only 20 pediatricians with 17 positive responses to come up with the slogan.
Example, 85% out of 20. How do we do that? We say 20 times 85 divided by 100. And that gives us 17. So we know that 17 out of 20 is 85%.
Now Jonathan shows another advertisement for a product, 100% Body Sensational. He asked the learners how they would measure Body Sensational.
try to tell me how you're going to measure 100% of body sensation.
You can't measure body sensation.
But we've got the results here. 95% of women surveyed felt that their skin was smooth. 76% felt that their body looked slimmer.
How are we able to measure body sensation? Are we able to measure? Can they justify that?
I guess they can't, but then they just write it for us to believe the ad, I guess.
Percentages only have meaning if what they are measuring is quantifiable. Often companies use percentages to endorse products because people tend to take percentages seriously. Jonathan has prepared some graphs on the board to show how deceptive a graph can be, depending on how it is used in the media. He has made up a graph based on an issue that the learners can relate to, how average marks for mathematics have fluctuated at their school over the years.
Okay, girls, imagine you were a parent of a girl at Macaulay House. How would you feel about looking at this, about the math results in Macaulay House?
So I'd feel disappointed and take my child out.
Okay, girls, so from this graph, we can see that the results are going down.
Jonathan shows the girls the larger graph that the graph they saw was taken out of. Now they realize that they only saw a portion of the graph and that the bit they saw did not tell the whole truth.
Look at the graph that we drew previously, which was from 1997 to 1999, which shows that Macaulay's House results going down, was this period over here, from 1997 to 1999. Okay, it shows that Macaulay's House results are going down, but overall, at the big picture, we see that results are going up. Now, how would you feel as a parent having to look at the larger picture of the results at Macaulay House?
I'd tell other parents to bring their child to Macaulay House.
He draws another graph showing how maths marks have improved, but does not label the vertical axis.
But if you actually have a look here, what type of percentages would you think should be labelled over here?
85% at the top.
85% at the top, yeah? And over here?
20%.
Girls, in reality, the percentages over here are only 60 and 63.
It is very important not to make assumptions about what is on a graph, but always to read the labels and insist that they are there. What happens when your graph's axis does not start at 0? The learners compare 3 different graphs in their groups.
Gradually, and then ends there.
The graph only increased by 2 units in a space of 12 months.
Now what we're going to do is have a look at the graph and what it would look like if we cut off a whole lot of the axes.
This graph is inaccurate because it starts off at 18 units, whereas a proper graph should start off at 0.
Okay, even though this graph was cut off, they still look the same. They're still going up gradually, don't you think?
I agree.
Okay, girls, sometimes they don't only just cut off the axes, but they even stretch the graph.
So yeah, it's the same amount. It's just that they label the y-axis differently.
But it all ends up being 22 units.
Yeah. Compared to this one seems to be going up quite steeply, and this one is more stationary, I guess.
Look at each of these graphs, okay, knowing that it's the graph of a petrol price. Which graph would worry you more?
This graph worries you more.
Why so?
Because it's a lot steeper than this one. But sir, even though this looks steeper, it's still one and the same graph, so.
The learners have started seeing how data and statistics can be used to manipulate people's opinions. From now on, they can look at data in the media more critically.
What I would like you girls to conclude about today's lesson is to look at advertisements with a keen and educated eye, that you will not be manipulated into buying products that are no use. Okay, girls, get the truth out of the advertisement and make your own decisions.
Okay, the program was very interesting because it was an eye-opener, and we could see that in the media there's certain distortions, especially with percentages and things that are intangible, so that you can't really calculate. So it was, yeah, a real eye-opener.
No, I actually enjoyed the lesson. It really helped me because most of the products I use, and they don't really work, and now I know why. So, yeah, I'd like to encourage people out there to actually really go through everything. They must really look at the stuff before they use them.
Lebogang, please get me 4 different colors of those.
Which ones? These?
Yeah.
1, 2, 4.
Yeah.
Hey, man, I thought about your problem. You should write a letter to the paper. And I've got the headline. It says, math teacher exposes dodgy maths.
And dodgy manager too. Hey, but do you think they'll print the letter?
Yeah, it's the responsibility of the media. They have to expose that, especially when it comes to statistics.
Hey, I should think about that.
So what are the responsibilities of those who work in the media, and how does maths literacy fit in? We spoke to Ferial Hafaji, an editor at Mail and Guardian.
I think it's important for everybody to be math literate. In journalism, it's very, very important for me because these days so much is about budgets. Once you understand budgets, you understand economics and politics, and then you can be an effective watchdog over power, over political power, over business power. That's why for me it's quite important. Journalists, I think, don't often pick up the mathematical tricks or the percentage play that goes on in politics, and what that comes down to is the importance of training. So you'd think that with political reporters it's just okay to give people an understanding of the huge body politic. It's also important that people have maths and numeracy skills because that's core to understanding politics. Politicians, yes, they are extremely clever, wily with their use of percentages, with their use of figures. So it's very important that we understand those. During an election, it's particularly important. For example, we had the ANC acclaiming a huge victory, but what we had to look out for is the number of people who had actually come up to vote. So to make those comparisons, again, vital that people do know basic math, do know basic percentages. The use of graphs and other forms of illustrations to help people understand stories is quite vital. For example, I think it's very difficult to understand national budgets without having access to tables and to graphs. For most people, though, who are not mathematicians, when you look at them, they can be very strange things that don't elucidate or help you understand or interpret. So therefore, the trick is to make them easily intelligible, and that means simplifying them. I often find making sure that the axes make sense, making sure that the graphic material is presented in a good and easy way. Often what I find in these reports is they are not easy to read. Let me take you to the specific example here. This graph tells you a very interesting story. It says that if you give people $2 a day, the poverty curve is going to be a lot less steep. Fewer people are going to be poorer. If you pay them $1 a day, you are increasing the poverty curve, and more people are going to be poor. So the graph shows you this important message, but unless it's not made simpler by us, because this is written by statisticians and mathematicians, we're not able to send out that message to a much wider audience. Information like this needs to be sent out to many more people than a small coterie of mathematicians and statisticians. As a South African, I can see its absolute value, because to have more maths literate people will mean that we're feeding into an economy that's choking for maths and science skills. As an editor, I can hope that what it will mean is that our journalists who are coming into the profession are going to have the maths literacy skills so important to doing their job well.
Hey, the weekend is here.
I also love doing this, just sitting on my bed and reading papers at the weekend.
I actually love the sports on TV section. Every game at a glance.
But you can't...
I'm just an ordinary guy. This will calm you down.
You everything but. Oh, sorry. How much is that?